Okay, we today are going to look at permutations, and this is again sort of thinking about how you order things and how you count things. We just did a section on counting. Kind of tell me what counting is about. Do you remember anything about counting?
Counting is you look at the events and you look at how they apply together.
Yeah, how many events do you have, and then how many different ways you can do them? So like if you have two events, E1 and E2, how many different ways can you do E1, event 1? How many different ways can you do event 2?
And then you multiply.
And you multiply those together. But key to this is, first of all, see if it's a counting problem, because you got to know the difference between counting and permutations. And then the second thing is you've got to look at the counting problem and you've got to figure out how many different events there are. Then once you figure out how many different events there are, then you got to figure out how many different ways each event can occur. Okay, so like if you were going to flip a coin 5 times, how many events would there be? 5. If you're going to pick 5 cards out of a deck, how many events are there? 5. Okay, so first of all, is it a counting problem? How many events, and then how many different ways can things come out? Okay, today we're going to do something different, which is permutations. Okay, and I'll just write this down. A permutation is an ordering of n elements. An ordering of n elements. Okay, what is the key word here, do you think?
Ordering.
Ordering. Okay, you're not counting, you're not counting, you're ordering. And that's the difference between counting and permutations. Counting, you're like counting how many ways something can happen. So like if I pick a card out of a deck, how many different ways can that happen? Like how many different?
Wait, you're asking for the answer?
Yeah, it's like 52, right?
Yes,
There's 52
sorry.
different ways that could come out.
Yes.
And then if I kept the card out, how many different ways could the second event happen?
Maybe 51.
And then the third, okay. But what if I picked 3 cards and each time I put it back? Well, then it would be 52, 52, 52, right? So you see, that's counting. But permutation has to do with ordering. Okay. A permutation of n elements, and this is kind of the definition. A permutation of n elements. Okay, and an element is different than an event, right? An event is something you do or something that is done. Like you have 52 cards and you do something to it. That's different than a permutation has to do with the elements. That would be like the number of cards or the number of something. A permutation of n different elements is an ordering of the elements such that one element is first, one is second, and so forth. So it's like you have them in order. It's like, how many different ways could you order them? All right, so let's say that I have cards. I have 6 cards. Okay, and now I'm going to ask you a question, which is the number of permutations. So if I ask you for the number of permutations, kind of just talk out loud. What am I asking you?
You're asking for the ordering of the elements.
It has to do with ordering, okay, but if I'm asking you specifically for permutations, I'm asking you like what about orders?
What is first? What is second? What is third?
Well, but you don't know. It could be, how many things could be first?
Six.
How many could be second?
5.
How many could be third?
4.
Because, I mean, A can't be first and second. Okay.
So it has to go down.
So if I'm asking you for the permutations, I'm asking you for how many possible,
First thing. Orderings.
or just orders. How many orders can they be in? So do you understand what order is?
Mhm.
Okay. So like, who came in class first today? Okay. How many possibilities were there for how many could come in first
2.
today?
4.
Well, we're going to count 10.
Okay, so 3.
Okay, so there would be 3. So how many possible first people were there?
3.
How many possible second people were there?
2.
And how many possible third people?
1.
Okay, so this is the way permutations work. So, you know, again, let's think of it. We have 6 cards. How many possible first cards are there?
6.
And then,
5. 4. 3. 2. 1.
so just think about it and tell me how many different orders could you put 6 cards in?
So you would probably add those all up.
So I would have 10, 18, I would have 20 different possible orders.
No. Would you multiply?
I would multiply them.
No.
Okay. So it would
So
be,
isn't this just like counting though?
well, no, there's some similarities, but this is looking at what order things are in. Or if I look at phone numbers, how many possible first digits do I have in a phone number? Not
9.
10, right?
Yeah.
Yeah, 10. How many possible second numbers?
10.
How many possible third numbers? You see? That's different than permutations because
So is it the same? Is it like the same of counting? Whenever you take whatever you use, you take it out.
kind of, but with counting, you're looking at more general events. Permutations are specifically about ordering. Okay, so let's go back and, you know, it's like counting is the number of ways something can happen. Okay,
And this is the number of
orders,
Okay.
putting things in order. It's ordering things. Ordering is different than counting. Because like a phone number, every digit could be the same. Okay, but this counting has to do with how many different ways you could arrange them. And so let's do it easy. Okay, let's say I have the cards A, B, C. How many permutations are there? Well, what's the first one? What, you know, like what's one possible order?
3.
No.
Like A, B, C.
Okay, A, B, C is one order. Now you've got to do these
You
logically. So let's keep A the
A.
same.
So it'd be A, C, B.
Okay. Is there any other possibilities with A first?
No.
No. So now we're going to put what first?
B.
And then what?
A, C.
Okay. B, A, C, and then B,
C, A.
C, A. Now, is there any other possible B's first?
No.
Now what?
C, C, A, B. C, B, A.
Okay. So this would be 1, 2, 3, 4, 5, 6. How many permutations are there?
6.
Okay. Now, this helps you see doing it this way, but if I had 14, would you want to do it this way? No. So let's see. How many possible first cards are there?
3.
How many possible second cards?
2.
How many possible third cards?
1.
So how many permutations?
6.
3 times 2 times 1 is 6. Do you see that? Okay, like if I look at this, how many permutations of these 6 cards? You told me it was 6 times 5 times 4 times 3 times 2 times 1. You could say the permutation of n cards. What would be a way to write this? Like if n is 6, it's 6 times 4 times 3 times 2 times 1.
Mhm.
So the permutation of n cards would be, how could we say it? You don't need a calculator, right?
Oh, you're trying to find like an equation?
In general, right? If I have 2 cards, the permutations are what times what?
The
If I had two
first
cards,
times the second.
oh, okay, but tell me specifically, if I have two cards, what are the permutations?
It's going to be 2 times 1.
2 times 1. That's what I was looking for. Sometimes it's not clear what I'm asking, so we kind of talk through it, but you understand. So what are the permutations of 3 cards?
3 times 2 times 1.
What if n is 4? What are the permutations?
4 times 3 times 2 times 1.
What if n is 5? What are the
It should
permutations?
be 5 times 4 times 3 times 2 times
So P of n is equal to what in general?
N and the exclamation point. I can't think of it right
Factorial. Close enough. Boom. Okay? So that's what you, permutations of n elements is n factorial. Okay, but sometimes that's all possible combinations, right? But then sometimes you have to read the problem. Okay? What if I say there are 8 horses running in a race? Okay. How many ways can horses finish first, second, and third? Okay, so like if you think if there was 8 horses, they could finish 1, 2, 3, 4, 5, 6, 7, 8, or they could finish 1, 2, 3, 4, 5, 6, 8, 7, or they could finish 1, 2. You see, you would have to figure out all the combinations of all 8 places, and that would be like 8 factorial ways that 8 horses could finish a race.
now. But you're just looking for first, second, and third.
Yes.
So you would do 8 times 7 times 6.
Yes, because how many possible winners are there?
8.
How many
8.
possible horses could get second place?
7.
7, because one's going to be in first place, okay? And then this is 6. So it would be 8, the permutations would be 8 times 7 times 6, which is equal to 336. Okay, so you understand, like, so how many elements do I have? Like in this case, you have to think how many on the horse race, and think carefully, what is in for the horse race?
8.
8. Because how many elements are there?
8.
8 elements. Okay, so n is 8. N is the number of elements. N is the number of elements. Okay? But we were looking at them how many at a time?
3.
3 at a time. Okay, this is what you are going to make or break. This is P n of R. And so this is permutations of how many elements
N.
looked at how many at a time.
R.
Okay? You don't want to get what and what mixed up.
N and R.
Okay? So in this case, we were looking at P of how many? Of 8. How many at a time?
3.
Okay. So this is the nomenclature, P, little sub n before it, little r after it. And this is the way you do it. P of n sub r is equal, because you did this because you're smart and you figured it out, right? But what if I had 150 horses and I wanted to know how many different ways you could have the first 7 places?
That'd take a bit.
Yeah, you couldn't do it that way. So you understand what permutations are, but you need an equation that helps you where you don't just have to do it by hand. So it is n factorial over n minus r factorial. Okay? So you looked at this, I have 8 horses and I want to know how many different ways they could come in first, second, and third. And so what should I write down? You know, I've got 8 horses and I want to know how many different ways they can come in first, second, and third. What should
So
I
it'd be
write
like-
down? P of what?
So it'd be 8.
8, you could say like
And
8
then
horses.
8 horses and then 3
times.
Like 3 different places. So then what's going to go up here?
8 factorial
8 factorial.
over n minus parentheses n minus, no, 8 minus 3 factorial.
Okay, very good. So now we gotta be smart now, okay? And don't just use your calculator to do this, okay? I want you to do these without a calculator because I want you to see how factorial works. So we're gonna have 8 factorial over what?
5 factorial.
Okay. And so don't put 8 factorial divided by 5 factorial in your calculator. Because real quick with factorials, you overwhelm your calculator and they can't do them because they grow so quickly. So I want you to,
Well, if you write it out, you'll quickly see that 5 can go like.
okay, yeah. So tell me what you got to do is you want the 5 factorial to cancel a 5 factorial. So tell me a way, Emmy, that I could write 8 factorial.
So it'd be like 8 times 7 times 6 times 5 factorial.
Yes. And now 5
And then
factorial.
the 5 factorial over 5
Okay.
factorial.
And then it's just 8 times 7 times 6, which you can do. Please do it this way instead of putting it in a calculator. Why do I want you to do it this way?
Because it's simpler.
It's simpler, and there's ones that your calculator won't do because, like, really quickly factorial blows your calculator up. But if you do it this way, you can reduce it. Okay? So, let's say that we have a coin club with 5 members. 5 members in a coin club. Okay? And you're going to elect a president and a vice president. How many different possible ways could you have a president and a vice president?
5 and 4.
Okay, so you're going to, okay, but let's do it this way. First of all, permutations. You want to
So
know
you
what
have-
is in
You have 5.
5, okay, and then what is R?
2.
2, okay. And so what is this equal to then?
5 factorial over 5
5.
parentheses 5 minus 2 factorial.
Okay. Now that's 5 factorial over 3 factorial. And Catherine, tell me how I do this.
And you're going to write it out 5 times 4 times 3 factorial over 3 factorial, which will come out to 5 times 4, which equals 4.
Which I think you saw right off the bat. Okay, so you kind of saw how to do it, but it's just this is an easy one that you're able to solve by understanding it. But I wanted you to put the equation in so that on the harder ones you've had experience of
Yes.
doing that. Okay. Okay, those are the possible orderings, right? We're talking about orderings, but now there's a second thing that you have to understand, and that is distinguishable permutations. And those are permutations that look different. Okay, so let me try to explain this. So let's say that I have cards, you know, A, B, and C, and I want to know just the old thing of how many permutations there are. So tell me the permutations of A, B, and C.
It'd be 3.
No, I mean tell me, like, let's just list them.
Oh, so it'd be like A, B, C, A, C, B.
B, A, C, B, C, A, C, A, B, C, B, A.
So there's how many permutations?
6.
Okay, of those 6 permutations, how many look different?
All of them.
So how many distinguishable permutations are there? 6, right? Because everyone's different. Okay, so in this case, 6 is 6. So for the problems we've done so far, the distinguishable permutations are all the same. All right, but now what I want you to see is I can give you 3 cards. I can put anything that I want on those 3 cards, right? So the first card has an A, the second card has an A, and the third card has a B. So now tell me the permutations.
It's going to be AAB, ABA, BAA,
And then what? B,
AA.
other A. So this is B, A, other A. This is B, other A, A.
Okay.
Okay. And now I have
So then you
A.
also have a second set of the A's.
I've got to put this A first, right?
Yes, sir.
So that's A what?
It's going to be AAB,
Mm-hmm.
and then ABA.
Okay. So you see now how many permutations are there?
6.
6. 6 permutations. How many distinguishable permutations?
Would be 1.
It's 3.
It's like
2,
that's the same as
3.
that, that's the same as that, and that's the same as that. So there's 3 distinguishable permutations. Okay, and so that is when, like, maybe the cards have the same things. Okay, so this is what you do for that. You have in elements, you have N1 of one kind, and you have N2 of a different kind. Okay? And the distinguishable permutations is equal to n factorial over n1 factorial times n2 factorial and on out. Like I could have n1, n2, n3, n4, n5, right? But I have n factorial over n1 factorial, n2 factorial, n3 factorial. Okay? So, like let's think of our 3 cards. A, B. I have to figure out what 3 things, or what number of things.
N number
Okay.
2.
What is n equal to?
A.
N is a number.
3.
3. What is n1 equal to?
2.
And what is n2 equal to?
1.
Right. Now I could have had 4 A's, 3 B's, 2 C's, 11 D's, right? Well, what you would do is you would still count the total, and then just however many different letters I would have that be like N1, N2, N3. Ask a question.
I think I get it.
Okay. It's just
So, like, you're counting the different numbers of how. So, like, say you had, like, 3 A's, 2 C's, and 1 B, so then it'd be, like, 3, 2. So, like, your N would be all of them.
yeah, 7.
And then
N1,
3, and then 2.
N2, and N2. I mean, N1, N2, N3.
Okay.
Okay. So let's do one. How many distinguishable ways can banana be written? Okay. The first thing that I should probably write is when I say how many distinguishable ways, I'm trying to look for what?
How many different ways?
And what do we call that?
Permutations.
Permutations.
What kind of permutations?
Distinguish.
So we're looking at distinguishable permutations, and I should probably write something down. It's equal to, tell me the equation before we start putting things in.
It's
N
n factorial
over n
over
1 factorial times n2 factorial, so on and so forth.
Okay, but like in this case, how many n's do I have?
7.
Do I? No, yeah, 7.
6.
Right. Let's make sure we do this carefully. 1, 2, 3, 4, 5, 6. Yeah, there's
You're
6
gonna have
in, but I'm asking how many, like N1, N2, how many? 3, right? Because I could have a B, that's N1, an A, that's N2, and an N.
Oh, okay. That makes sense.
Okay. Distinguishable probabilities. Okay, what is N?
7. I think that's what we counted.
1, 2, 3,
No,
4,
it's
5, 6.
6.
Did I spell banana right? Okay, that's 6 factorial. Okay, what's N1?
It'd be 1.
1 factorial. What is N2?
3 factorial.
3 factorial. And what is N3?
2 factorial.
2 factorial. So that's equal to 6 factorial over 3 factorial times 2 factorial. Okay, so let's do, first of all, 2 factorial is just what? 2, right? And now I have 3 factorial. What should I do in the numerator?
Write out the 6 factorial. So 6 times 5 times 4 times 3 factorial.
Okay, 3 factorial makes 1. And then 4 over 2, I'm left with a 2. 6 times 5 is 30, times 2 is 60. Okay, so like if I ask you to sit down in how many different ways, distinguishable ways, because we had to do that because if I did that and that, if I switch those two A's, it's not distinguishable, right? So I can't count that. So if I asked you how many different distinguishable ways could you rearrange the letters of banana, you would never be able to do that by hand. You would get confused and you would go crazy. But it's just, you got to see, okay, there's 6 letters, N is 6. There's 3 different types of letters, so I'm going to have an N1, I'm going to have an N2, and I'm going to have an N3. And then you put the numbers in and you get an answer.
I'm just making sure I understand this right. So we had like 1 factorial, 3 factorial, 2 factorial. The reason like we didn't rewrite 1 factorial is because it's just 1. Right. Okay.
Exactly. So there's a 1 out there.
Okay.
Okay. Very good. Homework. We are in Chapter 9, Section 6. Did we do 25 last time, or did I tell you not to do 25?
Yes, you did 25.
Okay. So we are
We
going
did like 7 through 25. Yes.
Okay. So we are still in Chapter 9, Section, we're in Chapter 9, Section 6, right?
Yes.
We're going to do 27 through 34, and we're going to do 40 through 46.